Now we will discuss on the chapter 2, Introduction to Aerial Photography. First, we will look into the principles of the remote sensing. So basically, what's the remote sensing? So it is basically the art and science of to acquire the informations about the Earth's surface without actually being in contact with it. And what does it mean by doesn't have any contact with it? So basically, when we do the data collections, we do the acquisitions, normal method, we have to go to the ground and take the samples physically, where all of it they have the contact with the physical touch of human being, machines, or something like that. But for remote sensing, we don't really do that. It is basically that we try to capture it from the remote distance of the surface and the system that we use. So how does it goes to the art? Because of remote sensing, basically we are dealing with the images like satellite images, radar system, LiDAR, aerial photography, and many more. Therefore, dealing with these kinds of images, it requires some art senses that we as a human being able to determine it as opposed to the machine. That's why remote sensing, we need to have what we call as a human touch. And how about the science? It's because as the science, we have with our own procedures and methods. Therefore, all of it must be documented properly. There are methods, there are techniques, there are theories. Therefore, it is a science itself. Okay. If try to look into the concept of what we have in our laboratory or viewing the skies through the telescope, that one is not remote sensing. It's because remote sensing is basically we wanted to investigate the Earth's surface. It's not the space, it's not other things. So any concepts that might be same as the remote sensing, but as long as it doesn't involve the Earth's surface, it is not considered as a remote sensing. So basically, is remote sensing a science or a technology, or it is both? So basically, it is a technology, kind of tools, new kind of tools, even though it already has been around since World War I. And it is a technology, and it is across most of the disciplines that we have now, as long as it concerns about the geography, environment, geology, climate, and many more. So adequate understanding of remote sensing knowledge requires, I wouldn't say some, but requires a lot of scientific knowledge. Let's say, take examples, if you are forestry people, right? Or you want to do this kind of forest monitoring using these aerial photos. Maybe you want to use drones, maybe you want to use some kind of system, satellites, so on. By only having the pictures without a proper forestry knowledge will not able you to do the analysis. Therefore, if you want to have this kind of understanding of the remote sensing images, you must have the proper scientific knowledge on that particular application. That's why we said that remote sensing is a tool, is a technology. How you want to adapt with the tool and your field of knowledge is basically is upon you yourself. So we'll try to look to define what basically remote sensing is. So remote sensing is basically a collection of information about the objects or the phenomena. What kind of objects? Basically like trees, buildings, roads, soil, something like that, water, and more. These will be the objects, or could be the phenomena. Example, temperature, climate, rainfall, and many more. So this is the phenomena. by using the sensing devices. So sensing devices could be the RGB camera, the normal cameras. It could be the specific cameras. It could be radar. It could be laser detection system that are not in physical contact, meaning to say it must be hanging. It's like this. This is the surface. Okay, it must hang. It's hanging or doesn't have any contact with the objects or the phenomena of the interest. And in between there must be some of the medium of the transmission involved. So in remote sensing specifically, there are two types of the instruments. First one will be the passive, the second one will be the active. What is the passive? What is the active? So basically passive means the system requires the external energy such as sunlight in order to illuminate the surface of the interest. While for the active, the system itself will illuminate using their own energy, source of energy, on the area of interest so that it can capture the information. So that one will be the definitions of the remote sensing. And now we look into the resolutions on the remote sensing. I think that most of you might have the idea of how resolution works in our computer, monitor, or for our camera. So basically, when we talk about our camera, the let's say your handphone, iPhone, the resolutions of the camera will be 12 megapixels, meaning to say for every pixel of the image it contains 12 million of dots, where those dots will form a shape and color of the images that we captured. So that's basically how the camera resolutions works. For the TV or for the monitor, it goes with the HD, Full HD, 4K or 8K, where the resolution might be as a 1080, meaning to say it consists of 1470 times 1080 pixels for the frame being represented for the whole frame. Meaning to say, the bigger the image, the bigger of the numbers, more better representations, sharper, and also the image will be more crispier. So that will be for the visual resolutions. But in remote sensing, it's beyond that. So there are 4 types of resolution, right? So what does it mean by resolution in this remote sensing? There are 4 types. The first one will be the spatial, spectral, temporal, and radiometric. Basically, for the normal image, it will go to the same as the spatial. Now we look to one by one. So what does it mean by the spatial? Spatial, also called as a ground sampling distance, where it goes to the representations of the equivalent of the pixel size of the images over the ground distance on the earth. So meaning to say, in remote sensing, we represent those pixels with how big the area being covered on the ground. Okay, and it will vary based on the different kinds of platform. Example will be the drone. Okay, if you use the drone, let's say DJI Phantom 4, 20 megapixel for the camera. If you fly over 160 meter, due to these 20 megapixels of the camera and many more, the representations of the Earth's surface over a pixel of the image will be about 1.12 centimeter, more or less. So this is how we represented it. The smaller the figures of the centimeters, the sharper the image, the better the representations. However, the area to cover might be smaller, as opposed to if you have pixels maybe about 5 to 10 centimeter per pixel. Mean to say you fly quite high, maybe about 1000 meter from above. You might not have a sharp image, but for one scene, one shot of the image might represent much bigger areas. So that's how it goes. Okay, that's why it is a higher resolution, means more pixels, more details of the image, larger the size. However, it might be smaller the area being covered. So basically this is how the spatial resolutions. Now you can see here, this is 0.5 by 0.5. Okay, it is very sharp. You can see the shape. For the lower resolutions, 80 meter by 80 meter, you only can see those pixels. However, the size of the image will cover bigger areas as opposed to these good images. Now we look into the spectral resolutions. What does it mean by the spectral resolutions? It is came from the word spectrum. I think we learned during our primary school that spectrum of color, it is about 7 basically. So it is the ability of the system to differentiate the different reflectance of the same object at different wavelength. Taking, for example, our eyes. Basically, the wavelength is everywhere. Okay, but our eyes, we only can capture this 7 spectrum, which is the rainbow color. So that's what our eyes can see. But as opposed to the computer systems, it can detect more. So in remote sensing, the ability to determine those different wavelengths, it could be the color wavelengths, red, green, blue, blah blah blah, could be the infrared, shows the capability of the sensing platform. So the higher the bands of different wavelengths, the higher the spectral resolutions. And we do have 2 types of the spectral resolutions for the system: multispectral. If you ever experience using these normal satellite images, let's say Landsat, let's say QuickBird, those images that you can find on the Google, what you call it? Is the Google map, yeah. Basically, the images came from those satellites. And if you ever play with the drones, the camera that being used is normal camera, where it comprises of 3 spectral bands, which is red, green, and blue, where those 3 combine together to create another 16 million colors that our eyes can see. But for the different kind of platform of the satellite platforms, they're able to detect those infrareds, wavelengths, and more. Those wavelengths cannot be seen by our eyes. Therefore, it's very useful, as most of the information about our world, the environment, the soil, the water, and so on, only being detected or can be captured through these wavelengths, which is infrared, shortwave, and something like that. Okay. So basically, that's about the spectral resolutions. And another one will be the temporal resolutions, where it's also known as the revisit period. So basically, it refers to the temporal frequency of which the same ground area being sensed consecutively by the same sensing system. Our satellites, they are circling the orbit. Okay. So when they circle the orbit, basically, you cannot ask them to take the photos of whatever places that you want ad hoc. So basically, we have to wait for the orbiting period. Over the certain period, then the satellite will eventually goes to the same place, take the photos, then you can get the images. So basically, it's a quite fixed date. So that's why the shorter period means more higher resolutions, and different satellite might have different temporal resolutions. However, there are some platforms such as aerial photo using drones, where you can fly it by ad hoc to get the photos. So that one will be different. Okay, and last one will be the radiometric resolutions, which refers to the ability of the system to distinguish the intensity of the radiant energy. So basically, it's about how good the system able to sense the wavelength factors of the intensity. The better it can distinguish the intensity, the more information can be captured. So the radiometric resolutions able to control the range of the pixels value of an image, and will affect its overall contrast. So basically, a fine radiometric resolutions is very critical in order for us to study those areas with a subtle variation of reflections. Okay, such as you want to use those for the to able to detect the minerals, chlorophyll contents, something like that, and more. On the coarse radiometric resolutions will make the pixels look like more or less the same. So that will be the the resolutions in remote sensing. Now we are looking into the elements of the remote sensing system. So we do have the sun here. As you see here is the sun, where the sun is the main source of the electromagnetic radiation, and the energy from the sun will goes to the target, which is the surface, and the atmosphere in between. So a lot of interactions happen within it, and from target, so the energy will be bounced to the sensors, which is the satellites. Satellite will detect it, decode it, save, and goes to the data retrieval storage from the ground and until to the analysis. So that's basically how it goes. And there are, as we discussed before, there are two types of the sensors, which is passive and active sensors. So we look into what is a passive sensor. So basically, passive sensor, it detects the energy when the naturally occurring energy is available, where it only takes place during the time when the sun illuminates the earth. Therefore, it only happens during the daytime. So the effective data collection will be during the daytime, and not much data or information will be able to be collected during the night time. However, there are some energies that is naturally emitted, such as the thermoinfrared, which is heat from the Earth's surface, can be detected day or night, as long as the amount of energy is large enough to be recorded, such as the forest fire and more. So it explains here how basically sun goes to the target and the satellite will detect it. But however, some of the emitted energy by the surface also able to be detected, but not really much. And in between, there are some atmospheric reflectance and absorptions happen, and all of this will explains basically or gathers the informations anything within the atmosphere until the Earth's surface. And remember that I also explained about the spectrum or spectral. So these are the visible light, as we see here, forms of the rainbow, and every distinct changes is considered as a spectrum. Although we see here as a form of 7 color spectrum, however, the computer will analyze and will determine it as a blue, green, and red. And from these 3 combinations will create a lot of colors. And you see here, most of the electromagnetic spectrums, they are not discrete. It is continuous data change over time. Therefore, intensity of the capability to identify or distinguish the intensity of the energy is very crucial in order to determine a subtle changes over the wavelength, as it will carry different informations by the different variations of the target. So what kind of aerial, or what kind of the passive sensors that we have? One of it is the aerial photo, either using the aircraft or using the drone to capture the image. Or the most popular one will be the multispectral imagery from the satellites. So examples: Landsat, Spot, QuickBird, and many more. And there are also the hyperspectral data information system, which is more than the multispectral, usually installed in the airborne, or it could be the handheld instruments, and it can go up to 400 bands. And another one will be the active sensor. So the active sensor, basically it overcomes the passive sensor disadvantage, where if the sky is covered with clouds, they cannot be used to observe the earth, as we know that it depends on the sun to illuminate the surface. If the sun, or if the surface covered by the cloud, therefore the satellites will only capture the cloud covers, and we don't really want this, especially when we are talking about the trying to look into the land use, the environment monitoring, and more. So the active sensors can able to detect the earth's surface even covered with clouds. Why? Because they produce their own radiation to illuminate the objects. So the energy that being created by the satellites, the active sensors, will be reflected by the surface and returned to the sensor. So what kind of system that mostly used? One of it is radar. So basically, for the active sensors, they are using the microwave. Ever heard before? Basically, if you try to look into the Wikipedia and more, the microwave oven that you use in our household is a byproduct of the radar system. Alright, so there's a long story about it. I think that you can try to find it in internet about the microwave oven, the history of the microwave oven creation, and you can see how it relates with the radar system. So basically, this microwave, it's called microwave because the wavelength is in the micrometer scale. Therefore, they can pass through the gases, as gases and clouds are finer than the micrometer, and even they can penetrate solids to a limited degree. So the microwave are generated electronically, and this artificial radiation emitted by the antenna, and this antenna basically produces pulses of energy of a non-wavelength, and it also vibrates through the certain orientation. If you want to know more about the radar, I believe that you can try to look into the internet about the radar system, especially in terms of the remote sensing system, the capability, the applications, many more you can find in the internet. Okay, so these are the orientation that, as I said before, horizontal or vertical. This is how the pulses of the wavelength being transferred to the surface. And now we will look into the image interpretation. So what's basically the image interpretation? It is about the examination of the images for the purpose of identifying objects and judging their significance. Why image interpretation is very important? Because it somehow is the most basic data interpretations of the remote sensing images, because it has been used since the first aerial photo was being taken in 1858. So we are trying to look into the elements that are quite obvious and easily being detected by our naked eyes, and also it involves some of the artistic elements to, and yet also the knowledge and experience, the familiarities of the objects in order to identify the objects on the images. So there are elements of the image interpretations such as location, size, shape, shadow, tone and color, texture, pattern, height and depth, as well as association. Now we look into one by one. Location. The idea is, where is the object? Where x and y of the object, the coordinates, where you can try to use the GPS to identify the location. And also size. Usually size can help you to distinguish the characteristics of the object. So you also can use as a quantitative measurement, such as the length, width, perimeter and area, or also the qualitative descriptions like small, medium and large, something like that. Example here, you know that this is the large field, so it might go to the football field and more. The houses, you can see how this building is bigger than this one, so you know that it could be either maybe schools, maybe halls, something like that, something that you can interpret. And also the shape, where the many natural and human-made features do have unique shapes. Usually for the natural is more abstract, human-made is more the shapes are uniform. Like this. Those three are human-made and this is the nature-made. You can see, you can easily detect this is the aeroplane, pentagon buildings, highway intersections, and also the palm trees in the forest. And also we look into the shadows, how important the shadows to the image interpretations. Basically, even though the shadows tends to obscure the objects so that we cannot see what's basically on the surface that been covered by the shadows, however, it helps us to identify what are the actual or the exact things that this image captured. We can identify through the shadows. Usually it provides information of the height of the objects. Either you can measure it qualitatively or quantitatively, like this. Taking the example here, these are some round objects. If you don't see the shadow here, you might not know that this is a water tank, and this as well. If the shadows doesn't exist here, we can't really understand why there's a rod on the road. Basically, it's a bridge, and the shape of this one. Without the shadow, you can't really interpret what kind of object it is. But with the shadows, it gives you a obvious manifestations of the object, which is pyramid. And another one will be the tone and color. So a band of the EMR recorded by a remote sensing instruments displayed in the image of the shades of gray from the black to the white. So these are the tones, okay, and it is related to the amount of the light reflected and being detected by the system in a specific wavelength intervals. So combination of those spectrums basically create colors. Let's say for the red band or red spectrum, in computer is only a shades of the gray carries the information of the intensity of the redness. With combination of the green and blue, it creates the natural color that you always see, like this. Different R, G and B. Oh, this one is blue, green and red. It gives the different intensity of the images. It shows different reflectance. The brighter, the more reflectance. The darker, less reflectance or no reflectance at all. That's why the first image is a blue one, because it reflects most of the blue color which is around here. The green one, it reflects some of the areas that carries the color of the cyan and the green, and the red one, it only carries the colors that is outside of the area here. So it can create some color of the yellowish, something like that. So if these three images being combined, it gives you a natural color. So color combination techniques be used to create a color composition image from the individual bands. So why we do this? Because humans, basically, we can't really able to distinguish the objects without the color that we familiar with. Therefore, this color combination helps human being to understand more. And of course, there are texture as well. So texture refers to the arrangements of the tone or color in an image, where it is useful because the earth features that exhibit similar tones often exhibit different textures, such as smooth, intermediate, and rough, especially when it relates to the soil surfaces. Like this, you can see the difference of the textures. Roughness gives you the idea of what is this, and this and this. Another one will be the pattern, where pattern is the spatial arrangement of the objects on the landscape. So basically, it's a random and systematic, where it goes to either nature made or human made, and also specific descriptions. So from here, the first image, as the images are quite uniform, they have some shapes and so on, we understand that this is a human made. But however, for the third image, it's quite abstract, right? It's non-uniform, it is a nature made. And height and depth, as discussed, shadows can often offer clues to the height of objects. Therefore, relative heights can be used to interpret the objects, either depth or the heights. So you can see it, you can understand either it gives you some depth or some heights, such as these images. This is an image of the coal mining in Germany in 1991. From the shades of the shadows, you know that this is a open pit mining is going down to the earth. And due to this shadow, you know that this is a chimney, tall chimney, something like that, and many more. And last one will be the association. So associations refers to the fact that certain features and activities, human activities, are always related to the presence of the other features and activities. And this is how basically we trying to relate with the land use. And you relate with the population, you relate with the social economy, and many more, by using this association of image interpretation. Right? Like here, you can see that there's a log here. You know that this is the logging camp, nuclear plant, something like that. That's all, and thank you very much.